Alice, you said you had homework question, specific homework question,
Yeah.
or questions at least.
Yeah.
You want to hit me with one of them?
9.3, number 9.
9.3, number 9. Okay. All right. So in 9.3, this is the separable differential equations section. So the idea here is that we want to get the P and the dP on one side and the T's and dt on the other side, right? As this is currently written, the right-hand side is our problem. So I'm going to need to do a factoring here in order to separate the P's from the T's, because I need it to multiply and divide things to the other side, because nothing is going to attach to a dt or dp if I'm just adding and subtracting. So if I look at that polynomial on the right-hand side, how many terms do I see? 4. What is our go-to factoring method for a 4-term polynomial? Factor by grouping. So to me, it looks like naturally to group the pieces with the p's together and the stuff without the p's together. So from the first group, I can take out a p. And from the second group, I can just take out a 1. So that's going to be p plus 1 times t squared minus 1. Which is great news, because now I've turned that addition and subtraction into multiplication, which will be easy to move now the pieces around to get and attach them to the dp's and dt's, right? So I'll divide both sides by divide both sides by p plus 1. And then multiply both sides also by dt. Then we'll integrate both sides. So to integrate 1 over p plus 1, I have to do a u substitution. But it's about the easiest possible, right? So the integral of 1 over u is natural log absolute value u. And I'm just going to plug the u back in. Everybody's good there? And then the integral of t squared minus 1 is? And we still need a plus c somewhere, right? I'm going to put it on the right-hand side because I'd assume I want to get the p by itself here, since it was dp dt, like p is kind of implied to be the independent variable there from that expression. So this answer could be correct, like we've solved it. If the back of the book probably has this in terms of p equals. So I'm going to keep on going a little bit to get the p by itself. So everybody go to the plan. So to get rid of the natural log stuck on the front there, what do we need to do to both sides? Exponent base e. Everybody's okay here? Now, remember when I have addition in my exponent, that's the same thing as like multiplying things with the same base, right? And e is a constant and c is a constant, so e to the c is still just a constant. So I'm just going to call that c e to the t cubed over 3 minus t. And then because it's absolute value, this could be plus or minus. and then we'll subtract the 1 over, and this I suspect is the answer in the back of the book. Is that it? Okay. Does that feel okay, Alice? Okay. So again, the trickiest piece was probably recognizing that at the start I needed to factor by grouping there, because if you didn't catch that, like, nothing was going to work out well for you. There's going to be no good way to attach or to separate the P's and T's in a way that connects them to the dP and dt, where we can integrate both sides. Did you have others? You said you had a couple, I think. You want to go for another? In this same section? Okay. Yep. All right, so one of them like this, right? These are the ones you're talking about? Okay. Well, it doesn't matter to me which one we do. Let's say we want to do... Which one do you want to do? Well, I don't know that we really need to do, I wouldn't worry about the change of variable problems. Let's try 20. So it says, find the function f such that f prime of x is equal to f of x minus, or times 1 minus f of x, and f of 0 is 1/2. The first thing that I would do with this is I'm going to rewrite this so that it's like in terms of y's, x's, and dy dx's, because that to me feels easier to do a separation of variables with. So obviously x is just x, and f of x is y, and f prime of x then is dy dx, right? So my differential equation we'd have is dy dx equals y times 1 minus y. Is everybody okay there? So to get that, or to separate things, I'm going to divide both sides by y times 1 minus y. Alice, you happy with what we've done so far? And then we'll integrate both sides. I think that, well, obviously this is just x plus c over here. What do we want to do with that? Well, that's not gonna, won't end up working out for me, I don't think. Because if I do that and let u equal y minus y squared, when I take the derivative, I still have a y stuck in it. Huh? No, what I think I probably need to do here is do a completing the square to get a tangent inverse out of this. Let's think about this for a second. So I'm going to take a negative sign out front so I can have a positive piece here. Everybody's okay? And, oops, dy. And I think that what I need to do is I need to have a plus 1/2 and minus 1/2 to complete the square. Oh no.
What?
That's not going to work either. I need that to be plus, oh no, wait, no. Do you guys see the problem with trying to do it this way? That's going to be the issue, right? Tan inverse, the antiderivative of tan, or the antiderivative, I'm sorry, the derivative of tan inverse is 1 over 1 plus x squared. I'll have a minus here. And cotangent is negative 1 over 1 plus x squared. So that one doesn't work either. What am I supposed to do here with this? Oh my God, guys. Oh no. Why don't I see what to do with this? All right, we've spent enough time. Give me a hint. I was trying to, but it wasn't looking like it was going to work because I'd end up with a -1 instead of a +1, which was the issue there. Yup. Oh, of course. Gosh, okay. Got it. All right, so we're on the right track, but we picked the wrong thing. Okay? So everything that we did was fine, right? Like, didn't work. What are the other options we have for integrating a rational function? I have polynomial division, which won't work because the degree of the numerator is less than the degree of the denominator. Or I have partial fraction decomposition. That's the option that I should have chosen here. And because the denominator was in a factored form, that should have been a Q. That is what I need. So I'm going to write it like this, because if I'm able to write it like that, then I can integrate each one of those two fractions separately with no problem. So I'm going to clear the fractions. I'll multiply through by y times y minus 1. And then distribute things through. So if I look, I see that negative a plus b has to give me 0 for the variable coefficients. And for the constants, we have just a is equal to 1. If a is 1, then b is 1, because negative 1 plus 1 is 0. And now we can do this. I'm going to do the u sub quickly in my head. Is everybody okay with me having done that?
Yeah.
Yes, sir.
How do you decide that A would be?
Well, if I look at the green stuff, the constants, I have A plus 0 B's has to equal 1. And if A is 1, if I plug that back in there, I can solve for B, and B is 1, right? Is that okay?
Yeah.
Okay. I'm going to compress these logarithms. So if I have subtraction outside my logarithms, I can compress them together into division inside the logarithm. And then we'll do the e to the both sides. And, I guess there's an absolute value here still. And if I drop the absolute value, I can put the plus or minus over there. But I don't really need to put the plus or minus over there because it can just be absorbed up into the C anyway. So you could write it with or without it. It's correct either way. But that's where I would stop. Because there's no way to get this in terms of y equals by itself. With the y's in two different places there in the denominator, it's just not gonna, you can't algebra it through. Or it's not worth it anyways. Maybe you could. I don't care to do it though. We did the important part. Alice, that was a workout. Did you feel okay?
Yeah.
Okay, I'm not convinced, but I'll let it go. Who else has questions from homeworks here, recent or past? Okay, we okay for today then? We'll do the same thing on Friday. I'll ask for questions from recent homeworks and you guys can do the same thing. So if you're making some more progress and you get stuck on something or you realize that you went back and been like, oh yeah, this one gave me a devil of a time. I'm not even sure that's right. Or like, I looked it up and like, this is the answer, but I don't understand how the heck we got that answer. We can deal with that next time also. For the remainder here today, I'm going to give you guys some practice AP questions that we're going to practice on. For Sammy or somebody, you want an extra one for Emma? Yeah. Will you see her and give her one? Sounds like she's still in school and actually leave to go in, didn't go home or anything. So what I'm handing you are the actual free response questions from last year's AP exam. Okay? So the format for your AP exam is you have a multiple choice no calculator section, multiple choice with a calculator section, a free response no calculator section, and a free response with a calculator section. What we're going to practice on today is the section 2 part A, which is 2 free response questions. So you're looking at questions 1 and 2. These are calculator active questions, so you should use your calculator to do them. There will be parts of them that can be done only with a graphing calculator. That is definitely something that can happen, whether it's a solving piece or an integral or something that, like, realistically you need a calculator to be able to do it. particularly in like a 30-minute time frame. Let's work on these questions 1 and 2. Make as much progress as you get. We're stuck on. If you're stuck on something, feel free to ask. You can talk to each other. Don't look them up. Don't Google them. We want to struggle our way through this. Like, that's where the real learning and understanding comes from. Is when you have to like really struggle your way through it and figure out like why don't I understand how to do this? Like, where's the disconnection? Skipping straight ahead to the answer. Like, oh, I can see the answer. That made sense. But it doesn't help you understand it later on, right? Like, you have to build those connections on your own. Everybody's cool?
Yeah.
Okay. So find a separate sheet of paper. Start working on 1 and 2. Ideally on an AP exam, you have 30 minutes to complete these 2 questions, so it's like 15 minutes per. To give you an idea of that, I wouldn't worry about time right now, but I want you to like, keep that in mind while you're working, is that you don't have infinite time. Feel free to look things up in your notes if you don't remember a formula, or Google a formula if you don't remember it. If you have to do that though, have a separate sheet of paper and start making a list of like, oh, I had to look this up. This is something I should have memorized, so I have a to memorize list starting as we're going through and doing things. If you have to look something up, or a fact that you should have known, or a procedure that you should have known, like start making a list of these things to start, committing to memory. You want to do that now because it's not easy to memorize some of this stuff overnight. You want to kind of get a list going sooner than later. As you practice, if you have to look things up, or you had to look up a procedure, look up how to do something, like start building a list for yourself to kind of do a review, and spend 5 minutes before you go to bed just kind of reading through that and start building the memory. The authentic long-term memory, so that it's there not just for tomorrow, but for the next day and the next day and the next day. Okay?
How well do people normally do on this exam in your classes?
I mean, every year there are students that get 4s and 5s, and every year there's students that get 1s and 2s. Like, it's hard to tell, like with the 1s and 2s, is this, a lot of times it felt like a student that just got to the first section, is like, you know what, I quit. Like, I yield, I'm done. Like, I could get a 2 or a 3 if I kept going and tried as hard as I could, but I didn't prepare. Like, I had intentions of studying, but I just didn't do it. So like, if you did the course the whole year and you've done reasonably well, there's no reason that like a 3 isn't kind of a reasonable basement. Considering a 3 is around the 50%. Like that's totally realistic, even if you leave some stuff blank, even if you can't finish everything. Remember that a 5 is basically like a 70% or better. So like, the general strategy, if you're trying to do well, it's either slow and really accurate, or try to get everything done. And I'm going to accept some mistakes and accept some guessing, but my goal is to try to get answers in on everything. I tend to think that fast usually does a little bit better than slow and perfect. Is fast and sloppy is usually better, because even if you're getting 80%, when you've gotten 100%, you get everything done. That usually ends up being more points than going slow and trying to shoot for perfect. Is that helpful?
Yeah.
So I think usually, like it's hard to get a 4 or 5. That doesn't happen by accident. You have to like be here all year, like engaged all year, and then you have to prepare, but like totally realistic for like, Peyton, you've done really well all year. I think totally realistic that you could get a 4 or 5 if you prepared. Like if this has been a struggle, you know, like, that's okay. You know, if this is a, you know, if this is a class that's gonna be pertinent to a career, you know, or a major going forward, even if it's like been a struggle, like spend some time studying for the exam. Even if you know you can't get a 4 or 5, like this is where all the real learning gets cemented in, and you build the connections between these disparate topics, is doing this review and doing this studying. And even if you have to take the course again at university, it'll, like that time, that couple, you know, the 8, 6, whatever you spent studying for the exam will pay off when you see this material again. Even if you're like, I don't think I can realistically get a 4 or 5, like I've struggled the whole year, and that's okay. But like there is value still to studying and trying to do the best you can, and maybe you surprise yourself, you know? Like maybe you're like, oh, and like all these things that didn't click in the moment have now started to fall into place, and because you're looking at it from, you know, from the finish line, you can kind of see how things are fitting together better, and it starts to make more sense. But, you know, is that enough of an answer? Yeah, sure. Okay, so let you guys work on these two for a bit, and we'll talk about them. And I'm not sure we'll go through everything today, because I'd rather like talk about like what are we supposed to be doing here, and let you guys come back and like after kind of a couple of hints or pushes in the right direction, try to take another pass through it before we go through and do it in earnest. Because again, like you struggling through this is the best studying, because it's going to force you to like build those connections that you have to have and have to come too quickly in the exam to be able to do well, right? Like speed becomes, you know, kind of paramount. The stuff that should be easy has to be easy, so that the stuff that's supposed to be hard, you can take your time with, and it can be hard, right? If you have a hard time with the easy stuff, you'll never get enough done to do well, kind of thing. Does that make sense? But if you nail the easy stuff, like 4 or 5 is totally realistic. Yes, you may.